This is the readout for Chapter 1.4, the Sine Law. Solving oblique triangles using the sine law, and solving acute angles using the sine law. Definitions to begin with. An oblique triangle is any triangle that does not have a 90-degree angle. So a 90-degree angle would make a triangle a right-angle triangle. To solve values in a right-angle triangle, we can use the SOHCAHTOA, sine, cos, and tan ratios from previous chapters. If it's not a right-angle triangle, we cannot use those. We have to rely on other tools, and our first one of those is this sine law. An acute angle is a triangle where all three angles are smaller than 90 degrees. And an obtuse triangle has an angle that is greater than 90 degrees. So in general, an oblique triangle is not a right-angle triangle, and there's two types of those, acute and obtuse. Acute, all angles are acute. Obtuse has one angle that is obtuse, or greater than 90 degrees. The formula for the sine law. In any oblique triangle with angles A, B, and C being labeled, the sine law states that side length A over sine of angle A is equal to length B over sine of angle B, which is also equal to length C over sine of angle C. Recall that when drawing a triangle, the lengths of sides are notated using lowercase letters, and the angles across from those sides are the uppercase letters. Now there's two versions of sine law. The first one has the lengths on the numerator, the tops, and the sine of the angles in the denominators. There's a flip way to use the sine law, and that's listed here. Sine of A over A is equal to sine of B over B, which is also equal to sine of C over C. So depending on which you need to find, you can use either version with the lengths in the numerators and the angles in the denominators, or flipped with the sine of the angles in the numerators and the lengths in the denominators. Note, if you can form an X pattern with an opposite side length and angle, you can apply the sine law. What this basically means is that if you're trying to solve for something in an obtuse or acute oblique triangle, and you have a matching side and angle combination, you can use the sine law. That means if you have both angle A and side A, you can use the sine law. Or angle B and side B, or angle C and side C. If you have a matching side length combination, you can use this. If you draw an X, that's another way to visualize this. In example 1, determine the length of side D. I look at our triangle in example 1. I have triangle DEF. I have angle D and angle E, as well as side length E. I have a matching angle and side combination for E, so I can use sine law. Another way to see that is to draw an X pattern. I can cross E's angle and side together with a line, and also draw a line between angle D, because that's a piece of information I have, as well as lowercase d, just because that's what the question's asking me to find. So all of these four pieces, my four ends of this X that is drawn, are relevant. Three pieces of information, and the last piece I'm trying to find, show an X pattern. Now to solve this X pattern, I'm going to use a version of the sine law. I'm looking for side length D. Now whatever you're looking for, if you're looking for side length D, use the sine law with the lengths in the numerators. If you're looking for an angle, use the other version with the sine of the lengths in the numerators. Basically, whatever type you're trying to find, pick the version where that's on the top. It will save you a step of algebra when trying to solve it. I'm looking for D, so I start with, on my left-hand side, what I'm trying to find, lowercase d. A sine law, length d over sine of angle d. So my left-hand side is d over angle D, and I have 40 degrees for that measure, is equal to, well, any other length over sine of an angle that we have. We could use, if we had it, length E over sine angle E, or length F over sine of angle F. We don't have that though, we have the E's, so let's use the E's. E over sine E is 38 centimeters divided by sine of 95 degrees. So first, set up your equation. D over sine D is equal to E over sine E. Then from here on out, we're going to be solving for what we need, which is side length of D. Now to find D, we'll use algebra and then use our calculator to find the trig values. We're right now dividing by sine of 40 degrees. To get D by itself, we should do the opposite operation of that. What is the opposite of dividing by sine of 40? The opposite is multiply by sine of 40. So we will multiply the right-hand side by sine of 40, effectively bringing it from the left to the right-hand side. This sets up a big line. Multiplying it is the same as putting it in the numerator. So my right-hand side is going to turn into 38 times sine of 40 degrees, and then still divided by sine of 95 degrees. If you'd like to do this in a couple steps, but you might be able to do this all in once in your calculator. Putting this in, 38 times sine of 40 degrees divided by sine of 95 degrees should give a value of 24.5, and that will be in the units of centimeters. The length of D is 24.5 centimeters. You can check to see if that looks reasonable, and compared to this side length, it does. Example 2. Find the missing angle B. In triangle ABC, find out what you have and find out what you need to solve. I have angle A. I have all three sides, side C, side A, and side B. I'm looking for angle B. If you're looking for an angle, use the version of sine law with the angles in the numerator, this version. Sine B over B is equal to sine of, now what two other angle side matches do I have? I have side C, but I don't have angle C. However, I do have both side and angle A, so we will use A. I can look at my X pattern and confirm that I can use sine law by showing I have pieces of information on angle A, side B, and I'm looking for angle B. So the version of sine law I'm using is sine B over B is equal to sine A over A. Sine B over B, 375, is equal to sine A over A, which is sine 35 degrees over side A, 220 meters. Now, again, from here on out, we're solving for B. Solve for B. We're currently dividing by 375. Opposite operations to bring it to the other side. Instead of dividing by 375, we should multiply by 375. That'll bring it across the equal sign. We'll be left with sine B is now equal to 375 multiplied by sine of 35 degrees divided by 220. And doing that big right-hand side in a calculator, it gives me a decimal value of 0.9777. I currently have sine B is equal to approximately 0.9777. I'm looking for angle B. Recall what the last step is to solve for an angle if you have the trig ratio. The last is to take the opposite of sine, which is sine inverse. So my last move will be to take the sine inverse of 0.9777. And on a calculator, that comes out to be approximately 78 degrees. My final value of angle B is about 78 degrees. So for sine law, first identify the information you have. Check to see if you have a matching angle and side combo. Then setting up sine law, what you're searching for, put in the numerator. If it's a side length, make sure all the side lengths are in the numerator, such as this form here. If it's an angle you're looking for, put the angles in the numerator, such as this form here. Fill in the information from the diagram. Then using algebra, move everything other than what you're searching for onto the other side, isolating for it. Then in the calculator, actually sub in and find its value. And if it was an angle you were looking for, then you'll have another final step, which will be to take the trig inverse to find the angle itself. So that's using the sine law. There are practice questions below, and below those, the answers as well as the solutions themselves. So try those out. Good luck, and we'll talk to you later.